Have you ever wanted to be able to do multiplication between large numbers without having to write the problem down? Have you ever wanted to impress your friends by being able to do difficult multiplication without a calculator? Well, if you have, then you're watching the right video. Today I'll be showing you some strategies for doing multiplication between two-digit numbers entirely in your head without having to write it down and without the aid of a calculator. So let's start off with a problem. So we have 34 times 21. Now these could be any two-digit numbers, and the process is more or less the same. This happens to be a pair where the strategy will work pretty well. But suppose someone told you this problem now, you might be like, well, I'm going to have to get out my notebook, get my pencils, sharpen my pencil, go back to elementary school. You gotta remember to put that 0 there. Okay, 680, 34. Sorry, this is kind of crooked, but so it comes out to 714. That's the answer. Great. But you had to write it down. You can't do this kind of thing in your head because you have to keep track of all these numbers and remember to keep the 0 there and then add them up, and it's hard. It's hard to do that in your head. Maybe you can, but it's hard. So the first strategy that I'm going to show you is a way to do this in your head that's easier than doing this in your head. And so obviously the advantage of the old method is that this will work for any numbers. This strategy, it will work for any numbers, maybe not more than two-digit numbers, though you could expand upon it. But in any case, the basic strategy is to look at these two numbers and think about which one is closer to a multiple of 10, and then write it as a sum of that multiple of 10 and another number. So in this case, 21 is only 1 away from 20, so we can write this as 34 times 20 plus 1. Now, it shouldn't be too hard to see that these two expressions are the same thing. 34 times parentheses 20 plus 1 is the same as 34 times 21, since what you do in the parentheses you would do before the multiplication, and so it's all the same. But now we can use the convenient distributive law of multiplication to distribute this 34 across the parentheses. So now we just have 34 times 20 plus 34 times 1, or just 34. So all we have to do to solve this problem, this problem up here, which looks like a difficult multiplication problem, is really this problem down here, which is a not super hard addition problem and a not super hard multiplication problem, or potentially two not very hard multiplication problems. So 34 times 20 is not that hard because it's the same as 34 times 2 times 10. And whenever you multiply a number by 10, you just put a 0 on the end. So really all you have to figure out is 34 times 2. That's not that hard. 68. Put a 0 on the end for the for the 20 instead of just 2, and then add 34. Now you have to do this mental addition, and this comes out to 714. And you can do this in your head. I don't mean to make it sound like you have to. In order to do this thing in your head, you have to think 680 plus 34. The way I do that, even though this video is not about addition, the way I do this is I sort of think about splitting it up. 680 plus 20 to get us to the even 700, and then I know there will be 14 left over by subtracting 20 from 34. But that's mental addition. Hopefully it's not too hard to arrive at 714. And you'll see this is the same as what we got using the traditional method over here. So it may seem laborious when I write it all out like this. It's like, well, I'm going to have to use paper to do that. I can't keep track of that. But the thing is, you can. What we're doing here is splitting it into really just two multiplication problems and then a sum. This, you have to do, 4 multiplications, and then remember to put the 0 here, so you have to be careful about order that you do them in and all of that, and then add them up. Here you only have to do 2 multiplication problems, 34 in this case, 34 times 2 and then 34 times 1, and then add them up. So it's not too hard, and you can get at 714. And the more you practice this, the easier it will get. By the way, when you split it up into a sum of the multiple of 10 and another number, it doesn't have to be a positive number. So if we had, instead 34 times 29, last time it was 21, so we could split this into 34, you could do 20 plus 9 if you wanted, but then you're going to have to do 34 times 9, so I don't know if you want to do that. Instead, you could do 34 times 30 minus 1, And now you just have to subtract 34 instead of adding 34 like we did with 21. 34 times 30, so now you got to do 34 times 3. These can be a little bit hard. I basically, in my head, do the same thing. So as an aside, 34 times 3, I split that into 3 times 30 plus 4, so I know it's going to be 90 plus 12, so that's 102. And then remember to put the 0 on the end. So that's 34 times 30, so we get 90 plus 12, put a 0 on the end, minus 34. So this is going to bring us down to, it's the same as 1,000 minus 14, so that's 986. And let me very quickly verify this with a calculator. Yes, 986 is the right answer. So there you go. So you can also do it with subtraction, basically. The second method is very similar, but instead of only splitting up one number, you split up both of the numbers. And so this is useful when they're not necessarily both close to a multiple of 10, or when one of them isn't. So say we have 73 times 46, okay? These, you could do 73 times 40 plus 6, or 73 times 50 minus 4, or 46 times 70 plus 3, so you could do all of that. But what I think is probably the easiest way to do this would be to split this instead. Split both numbers, so 70 plus 3 times 40 plus 6. And so now you just have to FOIL out this sum, which FOIL is just a term for first, outside, inner, last. It has to do with how you multiply sums like this. But you end up with 70 times 40 for your first number, I do it this way to go stepwise. Instead of multiplying everything out and then having to keep track of each number, I only keep track of two numbers at a time, and I'll elaborate on that in just a second. But 70 times 40 is the same as 7 times 4 with 2 zeros on the end, so that's 28 2 zeros. So the next number is 70 times 6. That's the same as 7 times 6 with a 0 on the end, so that's 420. And this is plus some more numbers, but like I said, I'm going to add these up as I go. So 2800 plus 420 is the same as 3,220. Now we have to add 3 times 40, so that's 120, or the same as 3 times 4 with a 0. If we add these up, we get 3,340, plus finally 3 times 6, which is just 18. Hopefully you have your single-digit multiplication memorized. So 3,340 plus 18, so that's 3,358, and that's the answer. So let me verify this. 73 times 46, 3,358. Perfect. So as you can see, we've arrived at the correct answer by just splitting each number into a sum and then going about it this way. The reason this is nice is that you only have to keep track of two numbers at a time, because you have to do the multiplication, so I have to keep track of 2,800 and 420 here, but once I add them, I only have to keep track of their sum. I only have to keep track of 3,220. And then I just log that. I can forget about 2,800 and 420. I just remember 3,220, and then keep adding more terms and taking the sum, and then forgetting about the old numbers. And the more you practice this again, the more comfortable you'll get, and the easier it'll get to do this. So those are the basic techniques. There's one more thing I want to show you, one more little trick, which is a special case. So this is if we add something like, say we have something like 33 times 27. So the nice thing about this is you can split this into 30 plus 3 times 30 minus 3. So the first number is the same, and the second number is the same, but just with a subtraction. And so this is taking advantage, by the way, of an algebraic property that if you have two numbers, a and b, the product a plus b times a minus b is simply a squared minus b squared. So that's a shortcut, and you can easily verify that if you just work it out the traditional way. You'll see that the inner terms cancel. But what this means is that 30 plus 3 times 30 minus 3 is the same as 30 squared minus 3 squared. So if you know your squares, or you can figure them out without too much trouble, you can do, so 30 squared is the same as 3 squared with 2 zeros, so that's 9. Wait, did I do that right? Yeah, minus 9. And so here we just get, in this case, 891. Is that right? Yeah, that's right, 891. So you see, we take advantage of this difference of squares formula to make these problems even easier. So that's it. Those are my tricks for doing mental multiplication. Hopefully you will now be able to impress your friends and baffle your enemies with your mental skill. And it's very easy to make up problems and practice this. I mean, all you need is you take a calculator and you punch 2 random numbers, and so you multiply them together, and then you try to do it in your head, and then you see what the calculator says, and the more you practice, the better you'll get at it. So thanks for watching, and until next time, goodbye.